Hi, welcome to this SIDEWALK video on how to create outline highlights on objects based on proximity to the player. I'll be performing a demonstration without explanations first, then after that going back to the beginning again to give a more detailed explanation. So a quick disclaimer about this method is that it's a very simple method. There are other ways to create outline highlights based on perhaps post-processed materials or even particle systems. So the method I've chosen is probably the simplest to set up to get what you want. And it'll be easy to explain the concepts as well. And it will be fairly useful for certain situations, like when you want to highlight objects within the 3D scene, right? And your player kind of gets close to it from the camera's perspective. Should you want to create a outline effect where you're more zoomed out, or the camera kind of zooms in and out very often, you will need something a little bit more consistent and more that has more fidelity to the screen. And then for those, I would recommend the other methods, right? Like the post-processed materials and the particle systems method. But for simple objects, right, and things that go close to the camera, this will be fairly effective and easy to set up. So let's begin. All right, so that concludes the demo. Okay. So a quick note, I experienced a crash somewhere close to the end, and then I had to restart and redo the material instance, right, which was lost during the crash. And also, I think because of that, I had to change some settings as well to this part of the construction script. Yep, in order to make it work. Okay, but that was just that was the demo, right? To showcase how to create a blueprint, right? As you can see now, I can place as many of these blueprints as I want into the scene, and because I exposed some of the variables, so for example, custom mesh, if I expose this together with the trigger scale, and let's see what else I can expose. Let's see. Okay. Yeah, I could probably just promote this value as well. Okay. And call this the outline size. Okay, and again, expose this. And then I'd be able to change these values, right, per object, okay, per actor within the scene. Okay. So for example, with this blueprint here, I can input a new static mesh like so, and you can see that the trigger volume that's surrounding the mesh gets instantly updated. Okay, and I can also change the size and so on and so forth, right? If I wanted to, I could also expose the material color, okay, inside the material so that I can change the outline color as well. Okay, but a lot of things, okay, a lot of things were done here, so I just want to go through everything step by step in detail. Okay, so to begin with, right, this whole process started with creating an outline material. So that's probably the most important part. Okay. How does this outline material work? Okay, and how to adjust its color and size and so on and so forth. Now, the best place to kind of start explaining this is actually to go into a 3D model, 3D modeling software like 3ds Max here, and show you a sort of an old school way of creating these outlines. So this particular workflow and this material that's created was based on this this old school method of creating outlines. You probably see this method in games like Okami, you know, these low, you know, games that develop on like low graphics end machines, right? Where trying to create complex shaders is a bit expensive. So what they will do is that they rely on polygons. So for example, in these games, you know, they'd have a lot of models, right, with very low polygon count. So they don't really mind doubling the polygon count because it wouldn't really affect that much. Okay, so for example, if you take a look like this, right, so as you know, right, polygons are single-faced by default, right? They're just rendered double-sided by certain software. And to kind of show you this, right, you can look at this teapot over here and see through, look through the gaps over there. You can actually see the back face of this teapot, right, on that side. But if you were to go to your viewport settings and turn on things like backface cull, or maybe I could just go to the object settings, that'll be faster. So I turn on backface cull over here, right? You can see, right, that those faces that I was referring to just now are now invisible, right? You're kind of seeing, you're only kind of rendering the correct face of the polygons, right? Okay, so now that we know that, about this backface cull thing, right, how they create the outline effect is that they would duplicate the entire mesh, right? And then after that, okay, convert this to editable poly. They would take all the faces in that object and then they would flip it so that it would face the other side, okay, rather than the side that it was supposed to. So we're going to take all these faces and then we're going to flip it, right? Okay, and if I put these two models kind of side by side, this is what they look like, right? This is the correct model, and then this is the model that faces the inward. Now, okay, so the next step of this process is that they will actually sort of scale up. Well, scale is not accurate, right? But they will take the polygons and they will push them out a little bit along its normal axis. So in 3ds Max, we'll put a push modifier, and then we'll gently nudge it out. Okay, so what you can see now is two meshes, right? And the flipped face mesh has now been kind of expanded a little bit, right, in terms of size. So it's kind of like going up outwards of itself, right? Then to complete this process, right, they will put in a say an unlit material, okay, something that looks like this, and then they will assign it to the outline mesh. Okay, so it can be any color, right? It can be red or green or yellow and whatnot. Okay, but I'm just going to use black in this case for this demonstration. Okay, so you can see the outline effect, right? So as you rotate the model, right, you can see that the outline changes, but really you're looking at the inside, inward-facing version of the mesh. Okay, so there are some advantages and disadvantages to this method. The advantage is that it's very easy to set up, okay, and it's not shader intensive. Okay, so it's just about polygon counts for this. The flip side of this is that it's not exactly perfect, right? So it's not really capturing the exact silhouette, right? It's actually taking the polygons, so you might see some cutting or breaks along the way, okay, depending on how the mesh is made. Okay, right. So now that we understand this, right, we come back into Unreal and we examine this process, right? So this process, how it works is we create a material, okay. Right, and then first off, we change some of the material settings. First, because it's an outline of the object, so what we want to do is we don't want this material to be affected by light. So we change the shading mode to unlit, and then we change the blend mode to masked. And then we also change the two-sided option to true, okay, so it renders both sides. Then after that, we would use a two-sided sign node. Okay, so this kind of outputs information to the shader depending on whether or not the polygon is facing the camera or not, right? And after that, we would inverse this information, right? And then attach this to the emissive color, okay? So then that way we will only see the inside of the mesh. So it's kind of like flipping the object. Then we will assign a color. So we would use a constant for vector over here and assign just a basic color to it, like say red, and then assign it to the emissive color. Sorry, I assigned this to the opacity mask just now. I should have assigned this to opacity mask rather than emissive color. So this is the correct setup. Okay. So the color here goes into the emissive color, and then the two-sided sign that's inverted goes into the opacity mask. Okay. Then now comes the pushing of the polygons, right, that we described just now. So for this, we would use the vertex normal world space, okay, which gets us the information of the vertex information in world space. And we would scale this value up. Okay, so we're going to put in a constant here, a scalar parameter, and we'll just set it as 0 first. And we'll multiply these two values together. Okay, and then put it into the world position offset. So this is the part of the material that will allow us to push the polygons in and out from its original position. So I can see that when we have this scalar parameter set at 0, there is really no change to the object. But if we were to kind of start putting in some numbers, then you kind of see a breakage of the model of the mesh, right? You can see a little gap happening over here. So this is the kind of this is the desired effect that we want right? So the larger the value, then the further away this object, right? These faces kind of move from the original position. Okay, so this is basically what the material will be like, and we're going to expose some of these values as well so that we can tweak them dynamically. So to do this, we have to convert these constant inputs into parameters. So we can right click and convert to parameter, and then change this, for example, to we're going to give it a name, say outline color, and we're going to convert this to parameter as well, and we're going to call this outline size, right? Okay, so this completes the material setup. Okay, and to demonstrate very quickly how this works is now we're going to place we're going to be placing objects within the scene. Okay, and this will be the visible mesh, and we're also going to place in a duplicate mesh in the exact same position, but this duplicate mesh will have the outline material that we just created assigned to it, like so. Okay, and then when we overlap them, okay, they'll be like this. Now, it's not visible right now because the outline size was set to 0, right? So to modify this, the easiest way is to create a material instance. Okay, so now I'm going to assign the material instance to the object. And then we're going to open up material instance. We're going to check outline size to tell the material instance that we wish to modify it. And we're going to change this value to, say, a number like 3, right? And then this completes the workflow. Okay, so this gives you the outline over the object. So as you can see, right, it's not too bad of an effect, especially if the object is seen from up close, like so. But if you go too close, right, you start to see little breaks in the outline over there. So there is some kind of trade-off in terms of the quality, right, for this easy setup. Okay, so as you rotate around the object, right, you can see that the outline sort of updates itself. Okay, so you would think maybe from here on, what we can do is just create a blueprint, right, and assign them, create a static mesh component with the visible mesh, and then create a static mesh component and assign the material instance to it, and then we're done. But what I'm going to show you in this workflow is to create a slightly more usable, user-friendly blueprint, so that you can adjust. You don't have to create a new blueprint for every object that you want to outline. So you can use this blueprint to, create, just assign any mesh that you want to it, and then have this trigger volume update itself on the fly. Okay. Right. So let's get into the blueprint. So for this blueprint, what we did was we created a blueprint class, an active blueprint class, and gave it a name, right? And then in the viewport, right, we created a collision mesh. And for this collision mesh, we selected the sphere collision, right? Okay, and we left this sphere collision at its default. And we rename this to trigger, something that we can easily find later. Okay. Next up, we would use the construction script to create the objects dynamically. So we will not place the objects here in the viewport. We will kind of construct them on the fly over here. So now within this construction script window, we will drag a line out here, and we will create we would say add a static mesh component, like so, right? So this is equivalent to doing it in the viewport and using an add over here, okay? But instead, we're going to do it in the construction script window. And after we added a static mesh component, we need to set the value of that static mesh component. So we're going to say set static mesh over here. Okay. And we're going to link up the return value of the component to the target over here. So now this component is created, and then this is going to set the mesh into that component. And for the mesh, we're going to promote this to a variable. Okay. We're going to call this my custom mesh. Okay. And we're going to expose it so that we can modify it within the editor, level editor. Right. Okay. So this is basically all you need to create the visible mesh, right? So we compile this and we set a default value for your custom mesh so we can see it. So we're going to set this to, say, a cube, like so. Okay, once again, compile. Now, once this is set up, if you went back to your viewport, you're going to see that the viewport now displays your cube, right, which is your custom mesh, okay, within the scene, right? So you know this is working. Okay, so the next part of this process is to basically duplicate this, like so. Okay, and just hook up everything so it's exactly the same, right? Except this second part is a duplicate of the first part, but this second part, we're going to be using it for the outline mesh, right? And to add to that process, we'll need to promote this component that we just created to a variable, okay, so that we can reference it later and change things, okay? So I'm going to now replace these links over here, okay, and just change this name to outline mesh. Okay. So there's no need to expose this. This should really happen kind of behind the scenes, right? Okay. So if you go back, if you compile and go back to the viewport, we're going to see that nothing is different, but really there are two cubes over here, right, being rendered within the same position. Then we need to assign this new outline mesh a dynamic material. Okay, so we're gonna create dynamic material instance. Okay, like so. Right. So we're gonna make sure that the target for this one would be the outline mesh that we just created. So you can you can drag it in from here and then hook this up like. So this material instance will be created on the fly and assigned to this static mesh component here. And we're just going to make sure that we point it to the material instance. Okay. Right. So the master material has been referenced and it's been assigned to the outline mesh. Okay. But again, we can't really see it just yet. Okay. Because the default value of the outline size was set to 0. Okay. So we'll get to that, right? But this part basically helps you define the outline mesh as well as the giving it the outline material that we created just now. So the final part of this process is to adjust the trigger volume, right, that we created at the beginning. So to adjust the trigger volume to the size, so we're going to do something in 2 steps, right? We're going to make sure that this trigger volume gets scaled to encompass the static mesh that we're assigning. And we want to also reposition this trigger volume to the center of that mesh. So we know that, you know, despite its pivot point or how it's placed, it's going to wrap around the object that you assign. So within this script here, we're going to take your my custom mesh variable, right? So this is the custom mesh that you created just now. Okay, and we're going to use a function here called getBounds. Right. So getBounds will basically return us a value of the size of, this static mesh, right? So what we're going to do is that we're going to split the struct pin so that we get access to some of those values. We're going to split this one as well. Okay. And then we're going to then get our trigger. Okay, and we're going to drag this out and say set sphere radius. Okay, so some of these components are very specific, right, to the object that you're using. So you may not be able to find it if you were just to right click on the screen here and say set sphere radius or something. So it depends, right? But usually it's safer just to drag out from the pin here before searching for the relevant node. Okay, so now that we have the sphere radius, we can then plug in, say, the x extend over here to the radius, right? And what this will give you is perhaps something that's very close to the size of the object. Perhaps you would like the highlights to appear a little bit earlier, right? So you want to increase the size, the detection size of this sphere. So in that case, what you can do is you can drag this out and say, multiply this. Okay. And you can promote this to a variable so that you can change this value on the fly. So for this value here, what we're going to do is we're going to change this to say outline size, right? Or detection size or trigger size. I think trigger size works best. Okay. And we want to expose this so that we can modify it on the fly. We will compile it and change the trigger size default value to say something like 2. Okay. If you go back to our viewport, okay, nothing has changed much. Okay, but we'll get to it. Right. So it hasn't changed because it hasn't been hooked up to the sequence yet. So we could connect this up. Okay, and compile. We should see some change. There you go, right, in the sphere size. Okay. Now, the next step is to then align this sphere to the center of the mesh so that the sphere can wrap around the mesh. Okay, so to do this, we're going to drag this out and we're going to now set the location, relative location of the trigger volume. Okay, so the target is the trigger and the new location will be the origin value of the bounds. Okay, and we're going to connect this to the new location and compile, and there you go, right? Now the sphere has been shifted to the center of this physical mesh. Okay, right, so we save this, and then we will wrap up this entire process by changing some values within the material instance. Okay, so to do this, we're going to go back to our trigger and we're going to add a event on overlap. Okay, and we're going to use the outline mesh, right, for this part of the process. So the outline mesh has been assigned a material instance. So that's why we can drag out from it and set the scalar value parameter on the material. Okay, we can hook this up. And we will set the parameter name to outline size. So this parameter name was defined inside the material, right? So we're just using the exact name that we used just now. So if I were just to hop over very quickly to look at it, right, that would be this parameter value over here, which by default we set to 0. Okay, so coming back here, if we were to overlap with the trigger volume, we would now like to change the parameter value to something like 3. Okay. Then we will also want to define what happens when we leave the value or when we get further away from the object. Okay, we're going to add on component end overlap. Okay, we're going to click on that plus sign there, and we're going to duplicate this to hook up to this and change the parameter value to 0. Okay. Now we compile. Okay. And that's about it. Okay. So that should give you, okay. There you go, right? When you leave, it will remove the highlight, and when you enter, it would show the highlight. Okay. So on the fly now, what you can do is you can select this in the level editor, and you can change the custom mesh to whatever it needs to be. Okay. And you can even change the trigger size if you feel that, you know, this is too close, right? You would like the highlights to come on a little bit earlier. Okay. Right, there you go. Okay. So, yeah, right. So that's the whole process of creating a outline material and assigning it to a duplicate of the visible mesh, right? And then having it kind of turn up when you're close to it, right? And hiding it when you're far away from it. So I hope this helps. Okay, thank you.